morning, students. Today we are going to start chapter number 3, Matter. We have already studied about matter in the lower classes. Anything that has mass and occupies space is called matter. All the matter is made of tiny particles called atoms and molecules. All the living and the non-living things which we come across in our daily lives are matter. Depending upon the molecular arrangement, the matter is classified into 3 types: solid, liquid, and gas. The characteristics of matter are as follows. Particles of matter are in constant motion. The particles have spaces between them called intermolecular spaces. The force of attraction between the molecules is called intermolecular force of attraction. The force of attraction between same kinds of molecules is called cohesive force. The following factors are responsible for the existence of matter in 3 different states, that is solid, liquid, and gas. In that, first one is the arrangement of particles. In solids, the particles are very closely arranged to each other, whereas in gases, the particles are very far from each other. The second factor responsible for physical state of matter is force between the particles. If the force is very strong, the matter is solid, and the force between particles, that is intermolecular force, is very weak, then the matter is gas. The particles, if they are closely packed, then the force between them is also very strong. If the particles are kept far from each other, as in gases, then the intermolecular force is also very weak. Solids. In the solids, the molecules or particles are tightly packed. As you can see in the figure, there is no space between the particles or molecules. Intermolecular space is very less. You can easily see in the diagram, the spaces between are very less. Intermolecular force of attraction is very strong because the particles are kept so close, so the force of attraction is very strong between the particles or molecules. They have a definite shape and volume because they cannot move from their place. So that is why the solids have a definite shape and volume, and they are highly incompressible because there is no space for the molecules to move. So the solids are highly incompressible. You cannot compress the solids easily. Liquids. In liquids, the particles are less closely packed. You can see in the figure, there are gaps between the particles or molecules. There are more intermolecular space as compared to solids. In solids, the particles were very close, but in liquids, there are gaps between the particles, as you can see in the figure. Intermolecular force of attraction is not very strong as compared to solids, as molecules are away from each other, so force of attraction is also less. They have a definite volume but no shape. Liquid takes the shape of the container. Suppose you take Water, 5 ml of water, volume will be 5 ml only. The volume of that water will be 5 ml. So the volume will be definite, but the shape it can take, if you keep in the glass, it will take the shape of a glass. If you keep it in bottle, it will take the shape of the bottle. If you keep it in a mug, it will take the shape of the mug. So it changes its shape according to the container in which it is stored. And liquids can be compressed to some extent. If you take a packet of milk and you try to press that packet, you can easily see the packet can be compressed. So the liquids are compressible to some extent. Gas. In gases, the particles are very loosely held. You can see in the figure, the particles are kept separately. Lot of gaps are between the particles. Intermolecular space is maximum in the case of gases. Intermolecular force of attraction is minimum because the particles are so far from each other, so the force of attraction is minimum. They neither have a shape nor volume. As there is no force of attraction, so the gases don't have any shape. They take the shape of any of the containers in which they are kept, and neither they have a volume because they can occupy as much space available to them. The gases are highly compressible. We can easily compress the gas. So these are the characteristics of a gas. So after studying the properties of the three states of matter, we can conclude that the three states of matter differ in their properties because of the intermolecular spaces between the particles, intermolecular force of attraction, also called cohesive force, and third, movement of the particles. What are fluids? The liquids and gases are called fluids because their particles move rapidly and randomly in any direction. Because the intermolecular spaces are more and intermolecular force of attraction is less in liquids and gases, so the particles can easily move, and that is why both of them are called liquids. What is Brownian motion? The random or the zigzag movement of the microscopic particles in a liquid or gas is called Brownian motion. A very easy example to demonstrate this Brownian motion is, you must have seen in a dark room when a beam of light is entering from any part of a window or a door, then you must have seen very light particles moving here and there. So those are actually the dust particles which are randomly moving here and there in the air. So that is Brownian motion of the dust particles, which you can easily see by your eyes. He is Robert Brown. He was a Scottish botanist and discovered the random movement of particles, and that is why that motion is called the Brownian motion on his name. Brown noticed a rapid oscillatory motion of the microscopic particles with the pollen grains suspended in water under the microscope when he was investigating the fertilization process in a flowering plant called Clarkia pulchella. This motion of tiny solid particles suspended in the liquid or gas was named as Brownian motion. Now we do an activity to study the properties of solids and liquids. The materials required for it are an apple, milk, knife, two different shaped containers. The method or the procedure will be followed as we take an apple and keep it in two different shaped containers one by one. We observe that the shape of the apple, which is a solid, it does not change on keeping on in the different shaped containers. Then we take milk and we place it in the two different shaped containers. The milk, which is a liquid, we will see it takes the shape of the container in which we keep. Now we carefully cut the apple with a knife. We will see that the shape of the apple changes on cutting. Now we try to cut the milk with the knife. We will observe that it does not change its shape even when we move the knife through it. So the conclusion which we draw is that solids have a definite shape while liquids do not have the shape. Solids can only change their shape when they are cut or broken, while liquids change their shape according to the shape of container. We do one more activity to show the smaller particles occupy the intermolecular spaces between the bigger particles. For this we take sugar, some pebbles and a jar. Sugar, pebbles and jar. We take the jar and fill it completely with some pebbles. We will see a lot of space between the pebbles in the jar. Now we take sugar and add it in the jar containing pebbles. The sugar particles fill the space between the pebbles. The conclusion is that the intermolecular space between the bigger particles is occupied by the smaller particles of sugar. Students, we have studied till now about the three states of matter: solid, liquid and gases. But there are two more states. One is plasma and the next one is Bose-Einstein condensate. Plasma is often called the fourth state of matter. It is formed by superheating a gas. It does not hold its shape and a huge amount of energy is present in it. It can be found on the earth in flames and lightning. The sun, stars and some other celestial objects are made of plasma. These two states of matter are not in the course. They are taught in higher classes. Comparison between the properties of the three states of matter: solid, liquid, gas. First, shape. Solids have a definite shape. Liquids have indefinite shape and gases have indefinite shape. Second property, volume. Solids have definite volume, liquids have definite volume, gases have indefinite volume. Next property, intermolecular space. Solids have very less intermolecular space, liquids have large intermolecular space and gases have very large intermolecular space. Next property, cohesive force. Solids have the strongest cohesive force. Liquids have weaker cohesive forces than the solids but more than gases. And gases have the weakest cohesive force. Next property, Brownian motion. In solids, the Brownian motion is slowest. In liquid, it is faster compared to solids. And gases have the fastest Brownian motion. Next property, compressibility. The solids are not compressible. Liquids have limited compressibility and gases are highly compressible.